This video is on complex numbers. So complex numbers really result from when you have the square root of a negative number. And we'll talk about what that means in a minute, but let's just talk about imaginary numbers first. So when we take the square root of a negative number, we will get what we call an imaginary number. So an imaginary number results from the square root of a negative number. Up until now, we would just said the square root of a negative number would be not a real number because there's no real number answer that you could get that would be a perfect square to give you a negative. But what we do is we really say that, that every square root of a negative has a factor of the square root of negative 1, right? So every imaginary number has the square root of negative 1 as a factor. And the square root of negative 1 is what we're going to call the imaginary unit, which is equal to I. So we say the square root of negative 1 equals I. And we're going to be using that. So whenever you have a square root of negative 1, we're going to simplify that to I, where I is the imaginary unit. It's equal to the square root of negative 1, but we use I to represent it. So let's take some examples and simplify them. And the way you simplify this really is by factoring out the square root of negative 1 whenever you're taking the square root of a negative. So if I said to simplify, let's say the square root of negative 4, just to keep it simple. Now we know the square root of negative 4 is not a real number because you can't take a real number and multiply it by itself to get you a negative. But what you can recognize here is that if you were to write this as a factor, you could factor out the square root of negative 1 times the square root of 4. In other words, the square root of negative 1 times the square root of 4 gives you the square root of negative 4. So square root of negative 1 is a factor times the square root of 4. And then we're going to write this based off of the imaginary unit. So the square root of negative 1 is what we called I. So you're replacing the square root of negative 1 with I every time you factor it out. And the square root of 4, well, we know that's 2. So we have I times 2, which we typically write as 2I with the I at the end. So 2I is the square root of negative 4. So from here forward, we're not going to say not a real number anymore when we're evaluating this square root. We're going to actually write it in terms of the imaginary unit. So the square root of negative 4 is 2I. The square root of the negative tells you can factor out a square root of negative 1, which tells you there's an I, and then you just take the square root of 4. So a lot of the times you're not going to write this intermediate step. It's really just here for me to show you as reference. What you're going to really say is square root of a negative, I know it has a factor of I. What's the square root of 4? Well, the square root of 4 gives me 2. So the answer is going to be 2I. So if I did another one, maybe the square root of negative 36, let's think about what that would be. Well, the square root of a negative tells you that there's going to be an I that you can factor out because it's the square root of negative 1. And then the square root of 36, well, that's 6. So the answer here is just going to be 6 times I, which is 6I. Let's take a look at another one. If I said the square root of negative 7, well, the square root of negative 7, the square root of the negative tells you there's a factor of I. The square root of 7, is that a perfect square? Well, no, there's no number times itself that'll give me 7. So you can't simplify that any further. It doesn't have any perfect square factors. So here you would write this as, just so you can see it, the square root of negative 1, that's going to give me the I, times the square root of 7. The square root of negative 1, right, is I. The square root of 7, you want to simplify like you normally would. The square root of 7, in this case, doesn't have any isn't a perfect square, and it doesn't have any perfect square factors, so you keep it as square root 7. So the square root of negative 7 is equivalent to I square root 7. And you leave it like that. If you can't simplify that radical any further, you leave it alone. So we are simplifying the radicals as we normally would. We just now, if we have a negative inside, take the square root of negative 1. If I said the square root of negative 12, let's try that one out. Well, the square root of a negative tells me it has a factor of I. And then the square root of 12. Well, is 12 a perfect square? No. Does it have any perfect square factors? Well, yes, it does, right? The square root of 12 can be written as the square root of 4 as a perfect square times the non-perfect piece would be the square root of 3. Right? So I, because we had a negative, so square root of negative always has a factor of I. And then 12, the perfect times non-perfect piece, perfect square factor for 12, the highest is 4 times 3. And then we want to simplify this. Well, this will be I, the square root of 4, we evaluate as 2, square root of 3 we keep, just like we normally would when we're simplifying here. And then you're left with, typically the way you write this is the coefficient of 2 in front, then the I, and then the radicals last, because you don't want the I to be underneath the radical. So 2I radical 3 is the exact answer of how the square root of negative 12 simplifies. So you really are factoring out I for the square root of negative 1, and then you simplify the radical part as you normally would. That's really all I did here. And at the end I just write it all together. Let's talk about some properties of I. Alright, so just as a note, we'll look at this together. So we know I is equal to the square root of negative 1. Well, if I equals the square root of negative 1, then what does I squared equal? Well, I squared is equal to the square root of negative 1 squared. Well, if you're squaring a square root, remember you're going to be left with the inside, so this is just equal to negative 1. So it's a property you should know. I squared equals negative 1. So you have I, and then if you had I squared, that simplifies a negative 1. That's a real number. You want to make sure you write it that way. And then what if I had I to the third power? Well, I to the third power, I could really write as I squared times I, just using the values I had before. Well, what's I squared? I squared is negative 1, and we're going to keep I as I. So I squared is negative 1, so it ends up being negative 1 times I, which really makes it negative I. So if I was looking at I to the third, you can always simplify that down to negative I. And then let's take a look at I to the fourth. Well, I to the fourth, well, that's the same as saying I squared squared, right? Because when you raise a power to a power, you multiply. So I squared squared, well, what's I squared? Well, I squared is negative 1, so we really have negative 1 squared. Well, what's a negative squared? Well, that's going to be positive, and 1 squared is 1, so this is a positive 1. So I to the fourth actually equals positive 1. Now suppose I was to do this for I to the fifth, right? I'm going to keep going with this. Well, I to the fifth, I could write as, it's the same as I to the fourth times I. Well, what's I to the fourth? I to the fourth we just found is 1, so it's 1 times I. And what's that equal? That just equals I. So I to the fifth now equals I. And what you can see is going to happen is, it's going to become cyclic. So I to the fifth is going to give me I to the sixth will be the same as I squared, being negative 1, I to the seventh, and so on. So by knowing this, right, just knowing I squared equal to negative 1, I to the third equal to negative I, and I to the fourth equal to 1, you could actually get any power of I higher than 4 and simplify them down to powers that are involved between, I to the first through I to the fourth, and then simplify those. Sometimes people see this kind of like a cycle. You start with I, and then you get I squared, which equals negative 1, and then the next one would be I to the third, which we know equals negative I, and then you get I to the fourth, which equals 1, and then back to I for any higher power. So what we're going to do is we're going to use this to help us simplify higher powers than 4. Really, the goal is you should always be able to write this, whatever it is. If it's I to a power, you should be able to write it as either a value with I to the first, or 1 or negative 1, right? So I, negative I, or negative 1 or 1. And the way you really figure it out is that you know I to the fourth is equal to 1. So if you can separate it out to something with the power of 4, or something that's divisible by 4, a power that's divisible by 4, and then something else, you always can cancel out the one that has a power of the fourth. And you'll see that through these examples. So if I said to simplify, let's take a look at I to the 26th power. Now remember, I said a minute ago, kind of casually, but I want to make this power to be a power that's divisible by 4. So the closest power to 26 without going over is divisible by 4. It's kind of like when you're simplifying radicals. Well, the closest power to 26 without going over is divisible by 4 is I to the 24th. Well, how many more do I need to get to 26? Well, times I to the second, right? So I to the 26th is the same as I to the 24th times I squared. Now, because 24 is divisible by 4, I can always write this as a power of 4, right? So I to the fourth power raised to a power. So 24 divided by 4, this would be 6, because 4 times 6 gives you 24. And this still times, I'll leave it as I squared here for now. And now you want to simplify. So the part that's raised to the I to the fourth, you know what that is. I to the fourth, according to what we have here, is equal to 1, right? According to either the cycle here or here. Anytime you have I to the fourth, that's equal to 1. So this is really 1 to the 6th power times I squared. Well, what's I squared simplified to? I squared is negative 1. That's something you should know. So I got 1 to the 6th times negative 1. Well, 1 to the 6th, that's just going to be 1 times negative 1, which equals negative 1. So I to the 26th power is equal to negative 1. Now, you know, I kind of showed a long way to do this, but really you should recognize, okay, well, I to the 24th, the closest power to that is going to be always, anything that has a power divisible by 4 will always equal 1, because you can always rewrite it as to the fourth power to something else. So anything divisible by 4, you know, always come out to 1, because 1 to a power is always going to be 1. And then whatever's left over, you want to use the other rules for I squared or I to the third. Let's take a look at another one. If I was to say I to the 13th power. So first off, is 13 divisible by 4? No. What's the closest power to 13 is divisible by 4? Will be I to the 12th times, how many more do I need to 13? Well, just I to the first, so times I. Now, what's I to the 12th equal? Well, I to the 12th, since 12 is divisible by 4, just equals 1, because you always could write this as I to the fourth to the third power. So this equals 1. And you can just write that. You don't have to show like the rewriting of it. If the power is divisible by 4, you know it equals 1. Times what's left over? Well, just times I. I to the first power we keep is I to the first. Don't put the square root of negative 1 in there. The whole idea behind using I is that we're replacing the square root of negative 1. So 1 times I is just I. So I to the 13th is equal to I, because it's 1 more than a power divisible by 4. Alright, so the key that we're doing here is I to a power divisible by 4 is equal to 1. Right? That's really what I'm using when I replace the I to the 12th, or when I replace the I to the 24th. It's always going to equal 1. Let's look at a couple more. So if I said I had I to the 11th power, so let's think about this for a minute. You want I to the 11th power, the closest power to 11 divisible by 4. Well, that'd be I to the 8th. Remember, you want the closest power without going over. And then how many are left over? Well, if I have 8 here, I need 3 more to complete the total of 11. So this 8 plus the 3 will give you 11 total. So I to the 8th times I to the 3rd. Well, what is I to the 8th? I to the 8th power, well, that power is divisible by 4. That's why we did it, is equal to 1. So we have 1 times I to the 3rd power. Now, that's going back to our cycle. I to the 3rd is equal to negative I. And you want to replace that as negative I. You don't want to leave it as I to the 3rd. All your powers should be I to the 1st power. Alright, so at the end of this, i's should all be to the 1st power with either a positive or negative in front, or the i's are going to reduce down to a 1 or a negative 1. So you have 1 times negative I, And 1 times negative I is negative I. So as long as you can remember, you know, the basic substitutions for I squared, I to the third, and I to the fourth, you can really simplify everything back down to I. In this case, negative I. Let's take a look at this one here. If I said I to the 32nd power, well, is I to the 32nd, is 32 a power divisible by 4? The answer is yes, it is. So if the power is already divisible by 4, right away you know that equals 1, and you can just write it. You don't have to you know, split this off because 32 is already divisible by 4, so it's going to equal 1. Be careful there. Sometimes people split this off and then they get, you know, answers that still have powers of I in there. So your powers of I at the end of these problems, when you simplify, should always be I to the first power, because everything can simplify down to either I, negative I, or negative 1 and 1. So, you know, once we know about I, those are imaginary numbers, we can talk about complex numbers. So complex numbers have, you know, a real and an imaginary part. So if I talk about complex numbers here, have the form what we write as a plus bi, where a and b are real numbers, and I is the imaginary unit. So we're just going to look at a couple examples just to kind of make sure we understand what we're talking about. So a and b are going to be real numbers here. I is imaginary. So we call the part with a, you know, the real part. We call the bi part the imaginary part. A and b are just real numbers. They're coefficients. You know, this has plus here. It could be a minus, though. The negative would go along with the b. So, for example, if I said 4 plus 6i, well, what's the real part? The real part is 4, the part that doesn't have the I with it. What's the imaginary part? Well, that's the part that has the I. So the imaginary part is 6i. So 4 plus 6i, you can't combine these. They're not like terms, so don't try to combine the 4 and the 6 and make it 10i, right? They have to be separate. They're not like terms. So if I said, you know, what's a and what's b here? Well, a is equal to 4, b is equal to whatever's in front of I, which is 6. Typically not too difficult to understand. If I said I had 2/3 plus 5/2 I, well, what's the real part? The real part is 2/3. What's the imaginary part? The 5/2 I. What's a? Well, a in this case is 2/3, just the real part. What's b? Well, b is the coefficient of the imaginary part, which is positive 5/2. Sometimes you might see this, like if I said we have 5, you know, 5 is a real number. It's really not a complex number, but you might see it written as 5 plus 0i. That still means 5 because 0 times I is 0, so it's still the same number as a real number 5. A in this case equals 5, the real part. The imaginary part, even though you have 0 here, b is equal to 0. Make sure if they ask you about that, you can answer that properly, because they might just show you 5. The real part is 5, the imaginary part b, the coefficient of the imaginary part b is 0. Similarly, if I said 0 minus 8i, if I just gave you negative 8i, the real part's 0, the imaginary part is negative 8i. So this complex number, the real part a, well, that's 0. The coefficient of the imaginary part b is negative 8. So now that we know about complex numbers that have a real and imaginary part, we can simplify them, and then we can work through some operations on them. So we'll just start by saying simplify here. So you simplify these by simplifying you know, both the real and imaginary part completely. And that'll be it. So we talked about simplifying the imaginary part in the beginning of this section, you know, when you had square roots and negatives. And then you simplify like you normally would to combine like terms if you can. So if I started with just 7 plus, let's say, the square root of negative 25. Well, simplifying this, 7, stay 7, plus, now the square root of negative 25, remember how this works. The square root of negative tells you that you're going to have a factor of I, right, times the square root of 25, which is 5. So you can't take the negative out of here. Sometimes people try to do that. You can't because it's inside the square root. You can't factor it out. But the square root of negative 1 that you could factor out becomes I times 5. So this is really 7 plus 5 times I is 5I. And remember, you can't combine these, are not like terms. So, you know, the complex number we have is 7 plus 5I. Right? The real part is 7. The imaginary coefficient b would be 5. Suppose I had this. If I said we had the square root of negative 48 plus the square root of negative 75. So let's simplify this. The square root of negative 48. Well, the square root of a negative tells us that we're going to have a factor of I, right? Because the square root of negative 1, so a factor of I. And the square root of 48, is that a perfect square? Well, 48 is not a perfect square. Does it have any perfect square factors? Well, we want to split it to the real part, or the perfect square factors and the non-perfect square factors. Well, 48, does it have a perfect square factor? The answer is yes, it does. What's the highest perfect square? It's a factor of 48. And be careful here. The highest perfect square factor, it's a factor of 48, is 16 times the non-perfect factor, which is 3. And we'll simplify that in a minute. Plus here, we have the square root of negative 75. Again, let's factor out the square root of negative 1, which is I. When you have the square root of a negative, that's the only time you take out an I. Don't take out I's if you don't have a square root of a negative. And then is 75 a perfect square? No. Does it have any perfect square factors? Well, we have to split it to its perfect square, highest perfect square factor and non-perfect square factor. The highest perfect square factor is 75. Well, it's 25 times non-perfect is 3. So now we'll simplify these. So I times the square root of 16 is I times 4 times the square root of 3, plus I times the square root of 25, which is 5 times the square root of 3. Because you can simplify those perfect squares now. And just rewriting this in the more common form, I times 4 is 4I square root 3, plus I times 5 is 5I square root 3. And now, can we combine these? Well, going back to our section on adding like radicals, as long as you have the same, radicand, same index, so these are both, the same thing on the inside, which is 3, to the same index, meaning square root. You can combine like radicals. Here are the coefficients here, though. You also have to have these both have I in them. If these aren't both imaginary, if this was real and this was imaginary, you wouldn't be able to add them together. But because this has an I and this also has an I, that makes these like terms. Think about how when you combine like terms, right? If they have the same variable, the same power, think of the I almost like that. So the I root 3 and the I root 3 is kind of like your, your variable piece when you combine like terms. 4 plus 5 would give me 9, and then I root 3 comes along. Now, if I asked you what's the real part, well, does it have a real part? The 9I root 3 really, doesn't have a real part. It's 0. So it's really like saying 0 plus 9I root 3. This is just, to show you in complex form, in the A plus BI form, in other words. Well, what's A? Well, A is just 0. What's B? Well, B is everything that's the coefficient of the imaginary piece. Well, that includes the radical 3. Don't leave that off. It's really 9 radical 3. So it's everything but the I, in case you were asked that. But this is how you would simplify it. Let's talk about how you might do operations on these. Actually, let's save that for the next video. So in the next video, we'll talk about operations on the complex numbers.